Okay, let's talk about modeling systems of inequalities. So if we read the first problem on this packet that you got, Mr. Pleacha has to buy breakfast for his homeroom again since they have met their goal for arriving on time. He will buy a combination of muffins and donuts. Altogether, he will buy at least 16 items. I do want to highlight that idea of at least. Um, that is going to be one of the key things that we have to pay attention to for the students to choose from. Muffins cost $2.50 each, and donuts cost $1 each. He does not want to spend more than $25 on breakfast. And again, he does not want to spend more than. So consider what that means in terms of an inequality. Okay, so you'll notice the structure of this. We're going to start off going back to the idea of VWAC. Let's define our variables. And you do have a little bit of a hint here. If you look here, the x-axis is down here, and that's telling you muffins, and the y-axis here is labeled as donuts. And what that means when we define our variables is that we're going to let x be the number of muffins, and we're going to let y be the number of donuts. Okay? And then continuing with the VWAC idea, we would write our system of inequalities. Well, the first one is going to be the idea that we have altogether at least 16 items. So thinking back to many of the other problems we've done like this, we would have x plus y. But now we have to know what the word at least means. And if you keep in mind, that means the lowest, so we really need greater than or equal to have more than 16 or 16 itself. So we have x plus y is greater than or equal to 16. And then the other ones, muffins cost $2.50 each, and donuts cost $1 each, and he doesn't want to spend more than $25. So we start by saying that our muffins are $2.50 each. So we take 2.5x, and our donuts are $1 each, so it's 1y. And if he doesn't want to spend more than, that means he'd be willing to spend $25. It'd be awesome if he spent less than $25. So we use the symbol less than or equal to 25. Okay? So there's our system of inequalities. Now keep in mind, the only way to solve systems of inequalities is graphically. So our next objective is to graph the inequalities. So the first thing I'm going to do is realize that neither one of these are in slope-intercept form, so let's do that for both of them. If I have x plus y is greater than or equal to 16, I start by subtracting x. We have y is greater than or equal to 16 minus x. I also have the information I know about that. I know that one has a slope of -1, a y-intercept of 16. I look at that symbol, which is greater than or equal to, so I'm going to have a solid line. And since it's greater than, I'm going to shade above. Okay? I also have 2.5x plus y is less than or equal to 25. I want slope-intercept form, so I subtract 2.5x on both sides, and I get y is less than or equal to 25 minus 2.5x. Once again, my four pieces of information. My slope is negative 2.5. My y-intercept is 25. It's less than or equal to, so it's another solid line. And I'm going to shade below since it's less than. Okay. Now, typically speaking, one of the harder things to do with this is actually get the points for the graph. Noticing, of course, that on this graph, the scales are not all going by ones, which makes things a little bit trickier. So what I'm actually going to do is slide over to my graphing calculator, and I'm going to put these functions into the calculator so I can get some points. So I'm going to go to y equals, and let's type in the first equation, which is 16 minus x. Now do keep in mind, I could just call this an equation. We are dealing with inequalities. The only thing this is going to do for us is get us some of the points that actually go on the graph. Okay, so I put in the function, I go to the table, and looking at the scales from the graph, so noticing that we have our x's are going by 1s and our y's are really going by 3s. They're labeled by 3s, really going by 1.5s all the way up to 30. So if I go back to my calculator and I take a look at that table, let's just mark down some of the points that we have here. So I'm going to make an XY chart. My y-intercept is 0, 16. I also see 115, 2, what do we got here? 2, 14. And notice that 14 is not a very good point to find on the graph. So we got 5, 11. I'm sorry, 2, 3, 13. Another not good point. 4, 12. Well, 12 is actually on the y-axis, so I'm going to write that one down. And now I'm going to look through the table and find a couple of more. If you notice, when x is 5, y is 11. That's not a good point to plot. 6, 10, not really a good point to plot. 7, 9, however, is. So what I'm really doing is looking through the table, and I'm finding points that are going to be easy for me to actually graph. So this is the table that I just marked down so that now I can plot those points. Okay, the point 0, 16 isn't even really that good to find, so I'm going to skip it for now. 115 is a good one, though. I can easily plot that point right there. 214, not so much. 412, though, I can do 412. It's right there. And 7, 9, I can also get 7, 9 is right there. Okay. Remember, it just takes 3 points to make a line, and I did focus on the easy to read points. If I had no other choice, I of course would have done some of the other ones and estimated where they were. This one is a solid line, so I graph my solid line through the points. Use the whole graph with an arrow. In this one, y is greater than or equal to 16 minus x was supposed to get shaded above. So I'm going to take this whole thing here and shade above. Okay. Now let's do the same thing for the other line. So I'm going to go back to my calculator, and let's go back to y equals. Clear that out. And now I'm going to do 25 minus 2.5x. And let's go to the table for that one. And once again, let's look through that and find some nice points. 0.25 really isn't. Let's see, 122.5 is definitely not. 220, not so much. 415 is definitely a good one. So let's mark down 415. Let's see. Not so much, not so much. 10, 0. I'd rather have another point, so I might have to estimate a point or two. I'll estimate 8, 5. And I am going to estimate the y-intercept at 0.25. Okay. So if I go back to my graph, this is the table I just copied down. Notice it's not in order because that's not really a big deal. I'm just plotting points on the line. Okay, so 415 is the first one I had, and 415 is right here. 10, 0 is right here. And see, those 2 points just really aren't enough for me. I'd rather have another one or two. So I'm going to estimate where 8, 5 is. Let's see if that's 3, and that's 4.5, and 5 is probably something like right there, and 0.25 is probably something like right there. Let's see if those create a line or not. Generally speaking, they do. I just want to make sure I hit the 2 points I definitely plotted. This, I'll make sure, was another solid line. So let's draw my solid line. I'm not going to put an arrow on this end because it does hit the bottom of the graph and negatives don't make sense. The last thing to do is this one gets shaded below. So again, just like I did yesterday, I'm going to use this as my border, and I'm going to shade the entire graph below the blue line. Okay. I do notice that I have some overlapping. I have some overlapping happening right here. Okay. So now we really just have to do so there's a graph of the system of inequalities. Now we're really at a point where we have to analyze what we see. Again, we've got the 4 regions of the graph. And the only region where we've got stuff that works for both inequalities is in this double shaded area right here where the solution set is. So now they ask us to state a possible combination of muffins and donuts purchased. Keep in mind that X is the muffins and Y is the donuts. So I'm going to pick any point I want in here in this area. So for instance, I might pick this point right here, which is the point 218. So a possible combination, if I consider the point 218, the 2 stands for the number of muffins, and the 18 stands for the number of donuts. Okay, and what they like to do is ask you for certain other points. They like to ask you if particular points would possibly work. For instance, could we have 9 muffins and 6 donuts? Would that fit both constraints? And constraints means the rules, the conditions of the problem. All right, so this is the kind of thing that we'll be doing for the next couple of days. We're modeling with inequalities and solving them using the graph. As usual, if you have any questions, please be ready to come in and ask. I will see you tomorrow.